Alright, so now we're getting to the fun stuff. We're going to be drawing a graph based on just this function alone. So it does look tough at first. There are steps to this, and the more you practice these problems, the easier they'll become. First thing is we set these equal to 0. And so the reason we do that is so that we can see, so that we can at least plot out these points here on the graph to see where the function will hit 0. First we see that each of these terms, so we have x squared, we have x plus 2, and then we have x minus 4. So each of these three terms are being multiplied with each other. So if any of these terms equals 0, then the whole thing becomes 0, right? So if we plug in a 0 here, then we'll get 0 squared, we'll get 2 here, and we'll get a negative 4 here. But because 0 squared is just 0, this whole thing will be 0. So we can put our first dot here, our first point at 0, 0. Just like we did in the last problem, we'll get x equals negative 2 and x equals positive 4. So we'll go ahead and put a little dot here, and we'll say this is negative 2, 0. We'll put another dot here, and we're saying this is 4, 0. So next we actually have to draw the function out. So the easiest way to do that is just plug in any value in between these points where the graph would be 0. So let's start off on the left side. We have negative 2 here as a 0, so if we take any x value that's less than negative 2, we can see whether the graph is going to be positive or negative. So easiest way to do that is we'll do b times negative 3. Now we can plug in negative 3 here, squared, right? And then plug in negative 3 here for x plus 2. And plug in negative 3 here for x minus 4. So this here is going to be 9 times, this is going to be negative, this is going to be negative 1. And this is going to be positive, I'm sorry, negative 7. So all in all, this 9 is going to be positive. We have two negatives being multiplied, which will create another positive, which means this whole thing will be positive. So we can come down here and come all the way down, but all of these y values here are positive, and we know that because we tried negative 3. And if you try negative 4 or negative 5 or negative 2.5, you're always going to get a positive y. So next we'll try a value in between negative 2 and 0. So we can try b of negative 1. We'll go ahead and make some room here. So if we plug in negative 1 into x squared, we can do this even faster by just taking each of these terms and seeing whether they're going to be positive or negative. So if we plug in negative 1 into x squared, negative 1 times negative 1 will give us a positive. And then we'll be multiplying that by doing negative 1 plus 2. That gives us positive 1, so this will also be a positive. And then if we plug in negative 1 into this x minus 4, we'll have 1 minus 4. And that gives us negative 3, so this will be a negative. So if we multiply 2 positive times a negative, we're going to get a negative. So all the y values between negative 2 and 0 are going to be negative. And then we can try another value here between 0 and 4. Let's just do b of 2. And we'll try this method again so that we don't have to do too much math here, but 2 squared will give us a positive 4. 2 plus 2 will also give us a positive 4. And then 2 minus 4 would give us a negative 2. So this would be a negative. And that will give us another negative. So we know that all the y values between 0 and 4 are also going to be negative. And then now we can try an x value that's greater than 4. We'll try p of 5. So if we plug in 5 into x squared, we'll get 5 squared. Plug in 5 into x plus 2, we'll get 7. If we plug in 5 into x minus 4, we'll get 1. And that will all give us a big positive number. And we'll just finish the graph off going this way. And that's more or less what your graph is going to look like. If you want to check yourself, plug this into a graphing calculator, and I promise you the graph will look more or less like this. So I'm going to go ahead and erase all of this so that we can do this last problem here. Okay, so for this next one, we have a negative on the outside. We have a term here, x plus 5, x minus 3, and then we have x plus 1 squared. So I'm just going to go ahead and rewrite this as negative x plus 5, x minus 3. I'm going to write x plus 1 twice, just to know that this function here is getting multiplied twice. Okay, so we can start out by first finding out what the y value will be if we plug in 0 into all of this. So let's just do c of 0, and we'll have negative 0 plus 5 times 0 minus 3 times 0 plus 1 squared, and we'll get negative 5, or a negative on the outside, and then we'll have positive 5 times a negative 3 times a positive 1 squared. So negative 3 times 5 is negative 15, and then we have a negative on the outside, which would make it a positive 15. So, and then 1 squared is just going to be 1, so this will be a positive 15. So on this graph here, we can have, we'll have 0. At x equals 0, y is going to be 15. And we can just write here 0, 15. And so that's how you get your y value when x equals 0. And next, we can find out where your y values are going to equal 0. So to do that, again, we can just set x plus 5 equal to 0. X minus 3 equal to 0, and x plus 1 equal to 0. And so on this number line, we can do, we'll have x equals negative 5, x equals positive 3, and x equals negative 1. I'll go ahead and erase all of this so we have some more room to work. Okay, so we found out that we're going to have x be negative 5. That means our y is going to be 0 at x equals negative 5. At x equals negative 1, y is going to be 0. And at x equals positive 3, y is going to be 0. So we can also get these points down on our graph. So that's negative 5, that's negative 1, and we'll say this is positive 3. And our y's are all equal 0. Again, you can label them if you'd like. Negative 5, 0, negative 1, 0, and 3, 0. So next we have to find out whether the y values are going to be positive or negative on the right or left side of these points. So let's start on the left side. We have negative 5. So on the left side of negative 5, we just take a value that's smaller than that. So we'll just do negative 6. C of negative 6. And we'll have a negative sign on the outside. If we plug in negative 6 into x plus 5, we'll have a negative 1. So that'll give us a negative term, and we're multiplying that times negative 6 minus 3, which would be another negative term. And then we'd have negative 6 plus 1, which would again be a negative term, but we're squaring it, so that actually gives us a positive term. So we'll have a negative times a negative times a negative times a positive. And so these two will create a positive, but then these two will create a negative. So ultimately, we're going to get a negative number here. So we know that all these y values to the left are going up like this. So next we can take a value in between -5 and -1, and we'll just do -2. It really doesn't matter which one you choose, as long as it's in between those two x values. So -2 would give us a negative on the outside. -2 plus 5 is a positive. A -2 minus 3 is a negative. And a -2 plus 1 is a negative, but it is being squared, so that's going to turn into a positive. So we're going to have a negative times a positive times a negative times a positive. So basically, we're going to have two negatives here, which will turn this whole thing into a positive. So all the y values between x equals -5 and x equals -1 are all going to be positive. And then we can test out what the values between -1 and 3 would be. But since we know we have a point up here, we know that all these y values are actually just all going to be positive. And then finally, we can test a value greater than 3. So if we take something greater than 3, we'll do c of 4. We'll have a negative on the outside. We'll have 4 plus 5 is going to give us a positive. 4 minus 3 is also positive. And 4 plus 1 would also be positive 5, so that will give us a positive, and that's squared. So all these three terms are going to be positive, but we have this negative here, which will turn the entire thing into a negative number. So we know that the rest of this graph is all negative numbers. And again, you can plug this into a calculator and you'll get a function that looks similar to this. So I did these two for you. I'll leave this first one up to you. It should be easier than these two. The only difference is you got to factor these. So do what we did with problem number 2. Find the greatest common factor for 16 that adds up to +8.